Hi guys, in this video we're going to learn how to draw a structure of glucose, fructose, galactose and mannose, and we're going to use some mnemonic to remember how to draw those. If you are wondering what these hand symbols are, they are going to be used for mnemonics, and I'll show you how in a bit. Let's first start with glucose. So glucose is a 6 carbon containing compound. So I'll just draw a small line, and it's an aldehyde, so I'll write C as well on the top, because it's aldehyde, and on the bottom we have our CS2OH. So now because glucose has 6 carbon, we're going to have 4 different carbon and OH and H coming from different ways in these 4 different carbon. So for glucose you could look at this hand, any of this. So it's kind of like saying fuck. My language is gonna be offensive, sorry for that. So sort of like showing its middle finger, and that's gonna go for glucose. So and the direction, the finger point down the direction of OH, so the first OH in glucose is coming out to be in this way, OH. The second glucose would be this way, the third OH would be this way, and the fourth OH would be that way, just like shown by the hand, and hydrogen everywhere. So that's our glucose. And now this mnemonic is also going to help for our hayworth projection, or the circular image of the glucose. Let's get started for that. So glucose makes a 6-member ring with oxygen here. It's easy if you just know that. So this is your carbon 1, 2, 3, 4, 5 and 1, and the carbon is going to come up here. And if it's a D-glucose, one thing you guys should know is if it's a D-glucose, the final CH2OH always comes to the top. If this was a L-glucose, then this CH2OH would have been in the bottom, but this is a D-glucose because our last chiral center OH group is to the right, so this is D. And now we have OH coming out of all these 4, and we're going to learn how to do that by looking at this hand again. So this hand points down, up, down, right? So this is going to point down, up and down again, just like these 3 fingers are pointing. You ignore the 4th one. So down, up, down, and there's going to be H over here, H over here, and H over here. Now if you guys are wondering, there's supposed to be OH and whether it goes up or down, the whether it goes up or down depends on whether this glucose is alpha glucose or beta glucose. If it's a alpha glucose, then the direction of this OH and this CH2OH have to be opposite if it's a alpha glucose. If it was a beta glucose, then I would have drawn it to the up, but I just choose to draw alpha in this case. So this is your alpha D glucose. So this is your alpha D glucose. So pretty easy. If you just remember this middle finger, then glucose comes easy. And fructose follows the same thing. You can remember the structure of fructose by the middle finger too. So you have fructose is not aldehyde, it's a ketone. So you have you have CS2OH on the top and comes down, and you have CS2OH on the bottom too. And fructose is a 6 carbon containing compound, but it's a ketose, and the second carbon is a carbonyl group. So again, you can look at this structure and see one comes this way, and this is this oxygen, but for this oxygen it doesn't really matter if you draw it this way or that way. Now the next one is going to go to this side, and this side. So you have OH coming out this way, and this way, just like shown by the hand. So and in hayworth projection, let's try to draw it. In hayworth projection, fructose makes a 5-member ring, so it's not a 6-member, and the reason it's 5-member is this O is going to attack this carbon, and 1, 2, 3, 4, 5-member ring. And so again, now this is a D fructose, and again, if it's a D compound, the CH2OH in the carbon number 5, the CH2OH that comes off the carbon number 5 would always be in the top, as long as this is a D compound. This is a D compound, so the CH2OH is on the top. Now let's start for 1, 2, just 2, because we're here in this carbon is this carbon right here, and we're going to have a CH2OH and another OH come out, and the direction of OH again depends on whether this is a alpha or beta fructose. So now for these two, you again look at the finger, so it points down and then up, so it points down, first one, and the second one points up, and remaining space is just hydrogen. Now let's look at this one. Now if this is a beta, the OH points up. If this is alpha, the OH points down. So in this case, let me draw beta fructose. If it's a beta fructose, the OH points up. The direction, if the direction of this and this are the same, it's a beta compound, and we have our CH2OH right here. So carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, this is our fructose. Now let's try to draw glactose and mannose, and it's pretty easy. Actually, before we draw lactose and mannose, let me just tell you a couple of modifications in this glucose. If this OH in this alpha D glucose is modified by NH2, then it's called glucosamine, or if this is NH3, then it's called glucosamine, and if this is NHCOCH3, then that is called N-acetyl glucosamine. I'm not really going to talk more about that. Let's draw glactose and mannose for now. Now again, glactose and mannose are aldose, and they have 6 carbons, so let me draw glactose first. Oops, sorry. So the first step, so you have the CH2OH in the, glactose and mannose are both aldoses, so you have CSO on the top, and you have CH2OH over here, and we're going to have 4 carbon in between, because both glactose and mannose contain 6 carbon. So for glactose, it's kind of like you are fingering someone, and you have the first one comes this way, the last one comes this way, both of them are the other way. So you have OH come this way, OH come this way, and the other two OHs are this way, and you have hydrogen everywhere. So this is your glactose, and this is a D-glactose, because this OH is coming to the right. If this was going to the left, it would be L-glactose. Now let's try to draw hayworth projection, and again glactose and mannose are going to make 6-member ring, and now probably you'd learn how to predict. Now for this one, this is a D-glactose, so is the CH2 is gonna go up or down? It's gonna go up, because if it's a D, it's this one always goes up if it's a D. And whether the OH on this one goes up or down depends on whether this compound is alpha or beta. So if this is alpha, is it gonna go up or down? If it's alpha, it's gonna come down. If it's alpha, the direction of this CH2OH and this OH is going to be opposite. If this was beta, the OH would have it on the top. Now we have 3 more OH to put, and you just look at the finger over here. So down, up, up. So just do that. Down, up, up, and you have hydrogen everywhere. And in this case, I drew a alpha D glactose. Now let's draw our mannose. Again, mannose is a 6 carbon containing compound. It's the aldose, so we have our CS on the top, CS2OH on the bottom, and for mannose, think of it like man. This is like how babies make their handgun. So man, they like to shoot a gun, so that's how mannose would look like. So you have 4 carbon over here, 1, 2, 3, 4, and the first 2 OH is going to be pointing that way, OH, OH, and the second 2 would be this way, OH, OH, and hydrogen everywhere. And is this a D mannose or a L mannose? If you guys thought it right, this is a D mannose, because your OH is on that way. So now let's draw the hayworth projection again. So in this hayworth projection, one CH2H is going to come from here. Is the CH2H going to be on the top or bottom? If you guys thought it right, it's going to be on the top, because if it's a D compound, this one will always be on the top. And the OH over here, whether it goes up or down, depends on whether this is an alpha or beta compound. Now let's say if it's a beta compound, whether is the OH gonna go up or down. If it's a beta compound, the OH is going to go on the top, because if it's a beta, the direction of this and this have to be the same. Now for these three, 1, 2, 3, you just look at the hand, up, up, down. So you have up, up, down. Thank you for watching my video. Hope you guys understood it. If you guys have any question, please post it below. Thank you. Bye.